few years back, Rand said that you couldn't possibly drive enough miles soon enough to simulate autonomous driving or to actually drive autonomous, but you guys are doing that with your simulation program. Hickey, why don't you tell us about what your program here?
Sure. So Cognata is a software supplier creating a simulation solution for driver assistance systems and autonomous vehicle systems to accelerate time to market responsibly. So driving 11 billion miles, the RAND number, would take something like 500 years with 100 cars driving 24/7. We close that gap and we accelerate time to market while ensuring safety by enabling those systems to be tested in simulation.
But the simulation is in real world conditions, right? Why don't you talk to how you have mapped out real world cities?
Sure. So we create highly realistic 3D environments in order to test cars in the environments that they would really face when they're driven on the road. So we can take you through a few steps of the demo here if you'd like to see a bit of what we do.
Sure.
So our system starts by introducing an accurate 3D model of the car being tested. We have a portfolio of about 40 cars, and we have a few here available in the demo. So let's take a typical SUV to get started. So we start by selecting a car. Next, Cognata builds highly accurate digital twins of the cities that you want to simulate. So we stitch together a number of data sources, and we automatically build these high precision city models. Let's take San Francisco here as an example for this demo. Next, we need to introduce the self-driving car to traffic and scenarios and other agents in the world like it would need to react to in the real world. So we do that in the simulation. So here we have a couple of typical scenarios. Let's just take one here where we're making a left on Lombard Street, San Francisco. The next step is to add more variables in terms of weather and environmental conditions that we need to be able to handle. So for here we have a few samples. Let's take a daytime, and we'll introduce a little bit of rain into the demo. Finally, the car needs to be equipped with sensors. So the various sensors that will be needed for an autonomous vehicle can be modeled from our system, and we place them on the vehicle so that the exact configuration of the real car can run through the simulation to see how it behaves. Let's look at the LiDAR data here. So what you see here is the sensor output of a 3D modeled car with a camera and a LiDAR running down a highly accurate model of Lombard Street being tested in this particular scenario. Here you can see the weather that we've introduced. Here you can see the accurate output of the LiDAR sensors from a couple of angles. You can see the intelligent agents, the other vehicles in the model that we're interacting with, the accurate infrastructure, stop signs, the pavement markings, the pedestrians. And here we're making the left-hand turn that we're testing in this particular scenario.
Now, there's some of the things, the objects that are beyond the car, the pedestrians and so forth. Can you have different scenarios for them, like the kid running out in front of this car and that sort of thing?
Absolutely. So we actually collect data from various geographies, from a number of sources, to create these agents, the other cars, pedestrians, to act as if they would, and similarly to the way they would in that specific geography. So we create geo-specific agents to be injected into the scene for the car to interact with, and they're exactly what the car would see in that environment in the real world. Of course, we can manipulate these agents to do particular behaviors like what you just asked about. We need to, for instance, replicate a regulatory test where a person steps out into a street, or a pedestrian crosses diagonally across an intersection. We can program all of that in the simulation.
So how do you get that data? Where are you getting the mapping data and the point data?
So for the digital twin, for the static layer, we stitch together around 7 different data sources to procedurally build up the pavement, the infrastructure, the road network, the surface textures of the buildings, the foliage, all of that. And we collect all that, and we procedurally automatically build up the environment.
And so it's dynamic, I assume, so you're updating it constantly?
Yeah, so I mean, the city infrastructures are built, but we can introduce all of the new variables, so we can change the way that the agents behave, how the driving behaves, how the weather acts, how the pedestrians move across intersections. All of this is dynamic, and all of this is programmable.
And so how long have you guys been doing this?
The company was founded in 2016, and we are focused solely on simulation software for autonomous vehicles and ADAS systems.
So are you getting major traction or traction from the major OEMs as far as using this?
Sure. So we're working with a number of customers in the autonomous vehicle and ADAS space between OEMs and AV developers. Just earlier this year, we announced a multi-year partnership with AID. They are the autonomous subsidiary of the Audi Group.
So how many miles have been driven in the virtual worlds you've created, if you can share that?
There's no limit to how many miles can be driven in the virtual world. We create our simulations and we push them up, we run them in the cloud. So the elastic, scalable nature of the cloud makes it really infinite. There's really no limit to how many scenarios can be run and how many tests can be created. It's a matter of due to the cloud scale.
So from an OEM perspective, I assume they just pay some sort of subscription or on-demand fee, and then you fire up the GPUs in the cloud type of thing?
Exactly. So the GPU, the cloud is completely scalable. It's completely elastic. So we can create or provide as many resources as the OEMs need for their specific tests.
Now, is there some data, given that you're looking kind of across the universe of different OEMs and stuff, does that kind of help you help them, if you will, by seeing things that they wouldn't necessarily see by themselves?
So having a partner for simulation that's focused across geographies, across industries, is really beneficial for AV developers to have an expert that's focused strictly on simulation. So that is our space. That's what we know. We know the geographies, we know the challenging situations, we're creating those scenarios. So we have a wide portfolio of solutions to meet regulatory requirements, geographical requirements, vehicle requirements, across the breadth of needs.
And speaking of regulatory, how do the regulatory bodies view what you're doing, as far as a stamp of approval type of thing? Do they see it as valid as driving out in the actual roads?
So what we see a simulation doing is accelerating the level of safety of those other types of tests, like on-road testing. We see simulation as part of a multi-platform testing combined with test tracks and with on-road testing. So simulation is a great place to start. It allows you to test dangerous situations, rare situations, all of those things that you won't often see on the street and hopefully never see on the street.
Well, I guess that raises the question. I mean, do you see regulators potentially using this as a gate before people can go to the next level of testing on street? First, they'd have to pass some, sort of gold standard simulation test.
It absolutely makes sense. We see this as a great tool, for instance, for accelerating the exemption process for autonomous vehicles today, to prove and to measure the safety and the improvement in safety of the autonomous vehicles in a simulated environment before putting them on the road.
Wow, you guys become almost the UL potentially of this industry, don't you, for safety in the roads?
We'd love to be able to provide customers with a 5-star rating to prove the safety of their AVs before they're out on the street.
And that, and you may be involved in this, but the PAVE program that was announced yesterday, the 24 groups that are coming together to focus on safety, is that something you guys are involved with as well, or?
PAVE is a great opportunity to educate consumers. This is what we see is exactly being necessary to get people to understand what AVs are capable of, how safe are they, and how can we show that they're safe, and why should you be comfortable working with these cars.
Yeah, and that 5-star rating thing, that's what triggered that it'd be a real stamp of approval.
Be perfect.
Well, I appreciate your time.
Thank you.